Hey guys, today I'll be doing LeetCode 150, a medium question, reverse Polish notation. It uses the stacked data structure. The biggest issue with stacked data structure is identifying the fact that it's a stacked data structure. I'll show you what I mean very quickly, but to give a brief overview of what stack is, I would say the best way to think about stack is like a bunch of sticky notes. So if you have like let's say a to-do sticky note collection and you've completed a task, and the way to complete a task is to put another sticky note on top of it, then the way you put it is on top of it, right? Because you don't want to place it behind it. It just want to make sense. So you place it on top of it, and if you wanted to undo and you wanted to see the task that you had previously, then you would take the sticky note off the top. And it's the same way with stack. They call it push and pop. These are the two methods. Both of these should run in O1. And the idea is basically having like a way to push an element on top of the stack and then remove from the top. We call it the LIFO data structure, last in, first out. And another way to think about it is like a container. And if we had, let's say, push 3, push 4, push 5, and it would look like this in code, by the way. You'd push 3, you'd push 4, and then you'd push 5. And that's how it will look. The last push on top, and then when you were to pop, it would bring out 5, then it would bring out 4, then it would do 3. Like this, top to bottom. And it's basically that. Now, reverse Polish notation, okay? I'll write down the first example here, and I want you to just first think about, don't even think about this stack, think about the way you would approach this. Do you see a way to write down the expression that's given in the example here? So could we rearrange this array in some way such that we could get 2 plus 1, right? And then times it by 3 and get 9. And take a minute, pause the video, see how you can rearrange this. See a pattern. If you can see any pattern, like how we are using some of the numbers in the arrays and how we are using some of the operators, think about it. I'll give you like 2 seconds. Just pause the video. I'll go on with the explanation now. But the idea is, if you have like a container and you put 2, then you put 1, and then you encounter the plus sign. Now what do you do with the plus with? You do it with the 2 and the 1. So we could say the 2 elements at the top of the stack, right? So we could say, okay, when we encounter an operator, then our operands, by the way, this is what I mean by operators and operands. This is called the operator, and these are called the operands. So if we consider the first ever operator we hit, where do we get the operands from? Well, the operands are the 2 elements at the top of the stack right now, right? So we'll take those 2 elements, and then we'll do the plus as they want us to do. So we'll do 1 plus 2, we'll get 3. Then we'll take this answer, right? We've popped these 2, they're gone. Then we'll take the answer, we'll put it into the stack. Then we come to 3, and then we hit the operator again, and this time we want to multiply. And guess what? We had 2 operands again over here, right? And so we'll use these 2, we'll take them off, we'll pop them off, and we'll do 3 times 3, 9. Now you see, we've hit the answer. And again we'll just store this 9 back into the stack, and now the stack would end up just having a 9. In array wise, it would look like just 9. Initially we were doing like this, so it would be 1, 2, and then we would do the 3, then everything. But yeah, at the end our stack would basically just have the expression evaluated, and that's the idea. store your operands in the stack. Easiest way to access them, optimizes it. Pushing onto the thing is also very easy, and all we have to do is keep in mind that if we hit an operator, then we just want to use the operands. That's it. And an operator will always have a left and a right. I don't want to get into the details of unary operators, stuff like that. That comes in C++, but just for the sake of this question, if you wanted to multiply, you wouldn't multiply 3 times something. Like you wouldn't write 3 times, right? You do 3 times something, some x variable. And that's what I mean by there will always be a left and right, which means there will always be one operand and the second. So you can safely, whenever you hit an operator, say, okay, there will be 2 operands in the stack at that point in time. Otherwise, it just wouldn't make sense. And now to show you the code. So let's consider operators. We'll make this a set, alright? We'll say plus, we'll say minus, we'll say division and multiplication. These are the operators. And we have a stack. The stacks are treated as an array, by the way. There's no dequee or anything like that. It's just an array. You can think of the stack as an array. The arrays in Python support the pop, and the push is basically an append. You can do a push as well. Now we have a stack, right? And the stack is for keeping track of the operands. So we'll traverse through. Okay, so for I in range, length of the array that we are given, so the tokens in this case, we will see if the tokens is in operators. So that means it is an operator, right? In that case, I'll hold on to this for now. If not, I'll write down the condition because it can get a bit wordy. But yeah, I'll write down the else. That means if it is not an operator, then it is by default an operand because there's nothing else in the input array. And then we would have else. If not, then obviously we'll want to keep track of the operands that we have. So we'll just simply append the integer version, right, to keep things simple, into the stack. Alright, now if we have the operator, let's see. So I won't write down the, no, actually I'll just write it down, no worries. So we'll say pop, right? So if we pop the 1 and 2, we pop 1, we have 1 over here, let's say hypothetically 1 over here, and we would pop another operand, then we would get 2 now, right? And then we would say check which operator it is. Okay, so if tokens I is a plus, right, then we will simply just plus it and we'll add the result to the top of the stack. That's what we did with 3. Remember, we added 3 on top of the stack as soon as we were done with 1 and 2. So we'll just do stack dot append operand 1, operand 2, sum of them. Now I'll just write this shorthand way. I'll just do tokens I won't bother writing the if and stuff. Then we will simply just do operand 1 minus operand 2 to the stack, right? If it is a multiplication, then just do the product. I'll move this down. And if it is a division, in this case for the division they want you to truncate towards 0. Now the way to truncate is you can either do op1, op2. This is floor division in Python, by the way. Floor division in the sense that if you were given 5 by 2, and 5 by 2 is 2.5, right? If we did the additional slash, we would round it down, so it's called flooring in mathematics, and we would end up with a 2. It would be an integer 2. uh, you would have seen this in binary search where you do low plus high and then you do by 2 because indexes can't be fractions, and if it is division, then like I said, you will just convert op1 by op2 into an integer that would truncate it, or you can just do op1 by op2, and that's it. And you would just append and append this, and at the end, like I said, the array representation of the stack would just have the 9 in it, so you would just return the element in the array, in the stack, sorry, like I said. So we would store 9 here, right, and then we would just simply return that 9, and that would be it. I would say this is the best question to get into stack. After this, you can try out next greater. I would say it's a bit more difficult, definitely. I think it requires a bit of understanding of how stacks work. Try out the easy one first and then move on to daily temperatures. That one is probably one of the other toughest ones, I would say, because it has a little trick to it. It's a medium.